Morning, everyone. Today we have the opportunity, and I'm taking my turn, to make the presentation of Sara Revolts. I hope I'm pronouncing your last name correctly. She's going to give us the conference. We're going to have a lecture with her with the topic about her education. She's having a bachelor in science in aerospace engineering, and she has just completed, well, in terms of time, she has completed the master degree in science in aerospace engineering. She's going to make the presentation. She's going to explain us what this career that is not very common for our ears, what it means, where it is involved, and what we can do with this kind of studies. Thank you and have a nice day. Please.
Yes, thank you so much for this introduction. I would like to thank all of you for inviting me to present today. I'm going to share my presentation in one moment. Okay. Well, thank you very much. As you have said, my name is Sarah. I have a master's in aerospace engineering. I'm currently working as a research engineer, and today I'm going to talk to you all about careers in engineering from my personal experience as an aerospace research engineer. So here is a little summary of what I will present to you. First, I will go over with you what is an engineer. Secondly, where can you find engineers? Then how did I become an engineer? What my job description is. And lastly, I will go over with you what are some general skills that are useful for engineering. And then at the end, if we have some time, there will be a moment for questions. So during this presentation, if you have any questions for me, make sure to write them down, and then we can go over with them together at the end. Okay? So what is an engineer? Well, in media, like TV shows or movies, engineers are usually represented as people wearing hard hats in construction sites, or people who are very good at math and science. And while this is true, it doesn't actually show what engineering is or what an engineer does. And at the center of it all, engineering is creativity, problem solving, and teamwork. In all of my experience working as an engineer, I always come into situations where people need to be creative, where we need to solve problems, and where we work as a team. So really, the definition of engineering comes down to problem solving. Problem solving is at the core of engineering. So when you're looking to solve a problem, when engineers want to solve a problem, we have to identify the problem with these three questions. First, we want to ask ourselves, what is the problem? Secondly, who does the problem affect? And lastly, why is it important for us to solve this problem? So with this mindset, when we outline problem solving with these three questions, we can really see that engineering and the role of an engineer is actually a very old career. It's not a career that was just developed recently. It's a very, very old career. And it probably was one of the first kinds of careers that ever existed. Any society that has been around in the past has had the need for an engineer. There's always going to be a need for someone to solve the problems. So one example I would like to show you as the basis of problem solving as an engineer in an ancient society is one from the Mayans back in the classic period in Mexico from 250 to 900 AD. The Mayans who lived in what is now known as Palenque in Tabasco had a problem. And so engineers had to come help solve the problem. What the problem was is that Palenque was located in an area with a lot of water sources. And sometimes there was too much water in the city. So the problem was, how can this water be controlled? When we go to our second question, which is who does the problem affect? This problem affected the people who lived in Palenque. It did not affect the people who lived in Mexico City, for example, but it very deeply affected the people living in Palenque. So why was it important to solve this problem? Well, if the extra water was not controlled, then the city would flood. And if the city flooded, the people would no longer be able to live there. So engineers had to help solve this problem. And the solution was to develop a system of aqueducts. Now, an aqueduct is a structure that takes water from one place to another place. There are all sorts of aqueduct systems around the world, but the one developed by engineers in Palenque is one of the oldest forms of aqueduct systems that ever existed. So their solution for the water problem was to design and build these underground aqueducts to move water around the city, which would help control how the water was delivered and disposed of in order to prevent flooding. So these engineers, way back then, so long ago, were able to take the problem and solve it. And this is really what engineering is at the core. So that leads us to the engineer design process. This process, this cycle, is something that I see and I use in my job as an engineer every day, as well as all of my colleagues. So firstly, the first step is to define the problem with the questions that I explained in the previous slide. You need to define what the problem is, who it affects, and why it is important to be solved. The next step is to identify the constraints. Now, constraints are a type of limitation for your problem. You all as students, for example, every time you have homework or a project, you have one certain constraint on that project, which is the deadline. When is this project due? The deadline would definitely be a constraint for any engineer. So for example, if we relate this step back to the Palenque example, one constraint could have been that the problem needed to be solved before the next rainy season. If there's a heavy rainfall during a certain time of the year, that will of course make the water sources get larger and it could increase flooding. So a constraint for the Mayans could have been that they needed to solve this problem before the next rainy season, for example. So as an engineer, the next step after you identify the constraints of your problem is to start brainstorming solutions. Now, when you brainstorm, what you're actually doing is just taking out all of the ideas in your head and getting them down on paper, getting them out in the open, talking about it with your friends, with your colleagues. I would believe that you all as students actually brainstorm a lot of the time every day. Maybe you want to outside of the coronavirus pandemic, if you want to hang out with your friends, you will brainstorm on what you can do. Will you go to someone's house? Will you go to a restaurant? Will you go play at a park? These are all examples of brainstorming, getting ideas out there before you choose the actual solution. So then the next step would be selecting the ideal solution. After an engineer brainstorms ideas for the problem that they need to solve, they will usually go through each idea one by one and list the positives of that idea and the negatives of that idea. Once you've listed the positives and negatives for each idea, you can clearly see which ideas are better than the others, which ideas would not be as ideal, and which ideas would be more ideal for the problem. So the next step would then be to select the ideal solution. Once this ideal solution, it doesn't always have to be one idea. Sometimes it can be one or two ideas, but generally at the end of finding the positives and negatives, you will end up with one or two ideas that are clearly better than the others. So once this ideal solution is chosen, the next step would then be to make a prototype. Now, a prototype is an example of that idea, or sometimes what we call a mock-up. This prototype could be made out of paper, it could be made out of really anything. It's just something to represent the idea that you have before its final version. So if I bring this back to the Palenque Aqueduct example, a prototype could have been, for the engineers, would be just to dig a hole in the ground or dig a little tunnel or dig a little channel to test to see how it could control the water. Once this prototype is created, you then move on to the testing phase. And as an engineer, the testing phase is very important and also very fun because you get to work through, you get to see if what your idea, if your idea actually works or not. You evaluate, which is looking at the results and seeing if it's what you expected or not. You test, evaluate, and then you see if you can make it better. So the engineers from Palenque, maybe they dug a hole, they dug a little channel, they poured water in, and say, for example, maybe they saw that they poured too much water in and it started going over the edges. Then, during their iteration phase, iteration means repeat and repeat, they would try to improve this prototype by maybe digging it deeper and making sure the water didn't fall out. Or maybe when they poured water in, they realized that the water didn't go anywhere. It just stood still, which that wouldn't have solved their problem. So what they maybe could improve on instead is making the channel at an angle so that gravity could help pull the water down and move it. So these three steps here, making the prototype, testing and evaluating, and iterating and improving the prototype, are all very important in the engineering design process because that's when you really see if your idea is going to work. And if it doesn't, you change little things bit by bit so that it ends up working how you wanted it to. Once the prototype works how you want it to, you then communicate the final solution, the final idea that solves the problem. And this communication is the final step in the engineering design process. And this cycle, all of these steps, is something I do in every single project I have. So now we'll move into where can you find engineers. So on this page, I've just kind of shown images of different engineers that exist in Mexico as well as the rest of the world, to kind of give you an idea of how many different types of engineers exist. So the first one over here is software engineer. Software is actually a type of instruction. It's usually expressed in code, so you could see it as coding. And what a software engineer does is write the instructions for what it wants a program to do. So if we want to see how a software engineer impacts your own daily life, all you have to do is look at your phone. All of the applications that you have on your phone, like Instagram, Snapchat, or WhatsApp, all have software behind them to tell the application what to do. So every time you open up Instagram and you want to like your friend's photo, if you double tap the picture or if you tap the heart button to like the photo, the software inside the application then tells the program what you want to do and then tells your friend that you liked their photo. So if any of that interests you, then a software engineering position could be something to look into. It's a very, very important position right now, especially with all the advancement of technology that we're seeing. Another type of engineering is a biomedical engineer. Now the word biomedical combines the words biology and medicine. So a biomedical engineer, for example, could work on things like developing prosthetics. If you are missing an arm or a leg, sometimes a doctor will attach a device onto you that acts as your arm or your leg, and this is known as a prosthetic. So biomedical engineers are very important at developing prosthetics because that is what is combining medicine to human biology. I also have over here an oil and gas engineer. An oil and gas engineer would find where and how to get oil and natural resources from deep inside the earth out so that humans can use it. We also have a civil engineer. Civil engineers design, work in construction and maintenance of all public works and things in society such as roads, bridges, sewer systems, and actually my example before of the Palenque engineers were a very, very early version of civil engineers. They would fall in this category. So afterwards, I have architectural engineers. Architectural engineers are important because they work very closely with architects. Architects are the people who design different buildings, and the architectural engineer will work with the architect to figure out how to actually make this design come to life. Another example I have is a material science engineer. A material science engineer will work with different materials and see how that material will behave in different environments. For example, a house that is being built in a very north part of Canada where it snows all the time will not be built with the same material as a house that is built in the north of Mexico in the desert. Inside a desert and living inside a very snowy area are two different environments. So we need two different materials to be able to build houses there. This picture is actually from a Mexican material science laboratory. So then my last example is the chemical engineer. Chemical engineers are very important nowadays because with all of this coronavirus discussion, a vaccine had to be developed, and chemical engineers work with chemistry and virologists to help develop different vaccines. So chemical engineers are, if you're very interested in chemistry, that could be an engineering job for you. So now when we look at all of these engineering positions, it's also important to recognize that each position is found inside an industry. There are many different industries, and in almost every single industry in the world, you will find a type of an engineer. So some examples are the health and pharmaceutical industry. In this industry, you will find the biomedical engineer and the chemical engineer. You have the oil and gas industry. In this industry, you will find the oil and gas engineer or mechanical engineers, for example. In the transportation industry, you will find automobile engineers, train engineers, aerospace engineers, mechanical engineers, electrical engineers, all sorts of engineers in the transportation industry. In the construction industry as well, you will find architectural engineers, mechanical, electrical, civil engineers, all types of engineers. This industry here in the middle at the bottom, the entertainment industry, that's actually an industry that people don't think of where you will find engineers. But if you're at a concert or if you're at an opera or a theater or even a movie theater, or if you're watching a talk show on TV, there will always be an engineer there who is in charge of making sure the sound and the lighting are exactly perfect. So in the entertainment industry, you will find a lot of sound engineers and lighting engineers. And then lastly, my last example is the agricultural and food industry. This is a very important industry for each country because there are a lot of civilians, there are a lot of citizens in the country that you need to feed. So the agricultural and food industry, you will find a lot of engineers working to make that possible. So for myself, I work in the aerospace industry. And as I mentioned, the aerospace industry can be found as a part of the transportation industry. I particularly work in the civilian aerospace industry. So I work with the airplanes that civilians, such as you or myself, will take to move around the world. On this page, I've just listed some examples of companies that exist around the world as well as in Mexico for the aerospace industry. I'll go over them briefly with you. The first one here I've written is GE Aviation, or General Electric Aviation. I believe they have offices in Mexico. They work on, they develop engines for airplanes as well as other things. You also have the Mexican Space Agency, AEM. That's an agency that completes space studies, similar to NASA. There's Airbus. This is a French company that makes airplanes, and then we have United Technologies. This is a company that's found around the world, mainly in US, and they work on a lot of different aircraft systems, such as the air conditioning system. You also have Embraer, which is based in Brazil. They make airplanes. There's DLR, which is a German research laboratory. There's Boeing, which is an American company that makes airplanes. There's Safran, which is a French company that works on a lot of different things, including engines and, for example, the landing gear of the airplanes, all of the wheels that the airplanes have to use when they're on the ground. I believe Safran as well, they have sites in Mexico in the state of Querétaro. There's also Pratt & Whitney, who make airplane engines. It's a Canadian company. Liebherr, another German-French company that does air conditioning systems. And lastly, I put down a company called Gulfstream, which they're one of the many companies that specialize in business and private jets. So they're in the luxury side of the aerospace industry. So personally, for how did I become an engineer? In these next two slides, I'll show you a bit of my education path and what I did to become an engineer. So first, I completed a 4-year high school degree in New York State in the United States. I graduated in 2008. And what I would like to say is during my high school, although I was interested in science, I was interested in space, my grades for math and science weren't always the best, but it was important for me to keep my mind open and be interested overall to know if it's something that I wanted to continue in the future. So even though I wasn't the top of my class for math or science, because I was still interested in space and interested in problem solving, I decided to apply to a university in Chicago called the Illinois Institute of Technology for aerospace engineering. So I completed my Bachelor's of Science degree in aerospace engineering between 2008 to 2012. It was a 4-year bachelor's degree. And then I decided to go on to complete a Master's of Science degree in aerospace engineering, this time in France. I moved to Toulouse, France, and went to a school that translates to the Higher Institute of Aeronautics and Space. And something I want to point out here is that if you're living in US or Mexico, a Bachelor's of Science degree is all you need to become and to work as an engineer. If I wanted to work in the United States, I could work as an engineer with my Bachelor's of Science degree. However, because different countries have different education requirements, in France, a bachelor's degree is not enough, and you actually are required to have a Master's of Science degree. So the choice for me to get a master's degree was my personal decision because I was interested in working in France. And in France, I was required to have a master's degree. So I went on to my master's degree, and now I'm currently living and working in France. So that leads us to my career path. In 2012, in between when I graduated from the university in Chicago and before I got my master's, I worked for a year. I spent 1 year working after my bachelor's degree. And I worked as an intern at a company called ME Engineering in New York. And this experience to me, this internship experience was very, very cool because it was the first time that I was seeing mechanical, electrical, and architectural engineers all work together. ME Engineering was a company that developed heating, ventilation, air conditioning, and plumbing systems for different buildings, such as hospitals, office buildings, and schools. So working there as an intern, I really got to see the use of teamwork and creativity in the engineering field. As well that year, I also worked as a high school math tutor. I tutored several kids outside of school in their math subjects. So that was a very important job I had. And then, as I mentioned, in 2013 is when I moved to France. So in between 2013, 2015, I was a student. And then in 2015, I was employed by my current employer. So from 2015 until today, I've been working as a research engineer in Paris, France. As a research engineer, we'll go into my job description now. As a research engineer, I act as a link between academic research and industry. Now, when I say academic research, that's the really theoretical part of research that is done in laboratories and in universities. And industry considers more the things that exist today in the real world, the real life applications. So as a research engineer, I really combine the two. I combine the work that is done in academia and the work that is done in the industry. My projects typically last from 6 to 18 months. And during these projects, I develop mathematical models that represent real systems. So I look at a system that exists today, and I see how I can replicate that system with math equations. Once I've developed these models, I simulate or replicate different scenarios on the models. In my job, I attend technical meetings, technical workshops where we do a lot of brainstorming, administrative meetings, and from time to time, I go to different conferences. So sometimes these conferences are in France, or sometimes they may be in a different country. So I get to do some traveling as my job as a research engineer. So a little bit more on my job description. I'm actually someone, in my job description, I spend a lot of time in an office building in front of my computer. And so my day-to-day activities include a lot of reading articles. I read a lot of bibliography or studies that people have already done. I regularly ask questions to my colleagues. Because I've only been working since 2015, I don't have a lot of experience behind me. I've only been in the industry for 5 years. However, I have a lot of colleagues who have been working for 10, 15, even 20 to 25 years that have a lot of experience and can answer my questions and my doubts that I have. So during the day, I spend time asking questions to my colleagues to learn from their experiences. As well, I always have to keep track of my work. At the end of the day, I always have to write down everything I learned, everything I researched, and sometimes tracking my work leads to writing a report or a presentation. So here I'll go into an example of a research engineering project that I could do. The first step would be my boss talking to me about a team project that I will work on with my colleagues. After that, I will determine what my tasks will be, what my bibliography review will look like, what documents I want to read, and then which experts I will consult, what other colleagues will I talk to so I can learn about the problem I need to solve. Then the teamwork aspect comes into play. Here I complete my work alongside my other team members. And then at the end, once my work is finished, the whole project from top to finish is presented to my boss and anyone else who is interested in the project. So here is when we'll go into the skills that are useful for engineering. So these skills are ones that I wrote down based on everything that I've just been talking to you about. I feel it is very important and useful to be able to have a global vision. Although as an engineer, it is important to pay attention to details, it is equally as important to be able to take a step back and look at the problem overall from a global standpoint. Secondly, it is important and useful to be a critical thinker. When I talk about critical thinking, it means that if you look at something or you read something You don't just take it at face value. If you're reading something, it's always a good idea to ask questions and try to ask yourself why this is the way it is. It's always good to be critical about what you're reading and what you're researching. Next, I've also listed the two characteristics that I mentioned earlier, teamwork and creativity. The creativity really comes out in the brainstorming process and the prototype making process. That needs a lot of creativity. Actually, something I wanted to mention earlier, but I forgot, when I was in high school, my favorite class was art. I loved being creative, I loved art. And I find that as an engineer, I'm really able to access that creativity in my daily work. So next, I've written result analyzer. It's very useful to be able to look at the result of your project and figure out what it means. I've also listed time management. It's important to be able to meet a deadline and to be able to organize your time in a way that you are not procrastinating. Another skill that's useful is curiosity. Curiosity is a very useful skill. If you are someone who looks at machines and wonders how it works, if you're someone who looks at an overall system and you're very curious about what's going on inside, that's an extremely useful skill to have for engineering. Communication is also useful. And when I say communication, I don't necessarily mean that it's important to speak loud. What I mean is that it is important to be able to transfer information from you to your teammates. So communication can be in the form of email, it can be in the form of one-on-one conversation, it can be in the form of a meeting. So communication, effective communication, can exist in many ways, and it's a very useful skill to have. The last two I've put down are innovation and open-mindedness. Innovation is also another word for creating, motivation to create, motivation to explore and develop things. It's a very useful skill to have. And open-mindedness. The world as we know it has been able to improve and evolve because engineers have been open-minded and not closed to change. It's important to be open-minded and looking forward to different changes that occur. So here I have a few slides left to go over kind of a conclusion on what I've talked to you all about. Overall, engineering is really about being creative, about solving problems, and about working in a team, teamwork. Engineering makes a really big difference in the world because all of the engineers in the past have allowed us to live in the world that we have today. This picture that I have here on the slide is actually a really cool picture to me. What it shows is the space shuttle developed by NASA, which is the vehicle that went to the moon and into space. It carried astronauts on there. It shows the space shuttle on top of an airplane. Now this might look kind of funny to some people, but actually one of the constraints, if you remember back to when I talked about project limitations or project constraints, one of the constraints to the United States NASA shuttle program was that they wanted to develop a space shuttle that could be reusable. They wanted to develop a shuttle that could go up to space and come back down in one piece. So the engineers then had to find a way to test that this space shuttle could land. So instead of wasting money and time by launching the shuttle up into space and waiting for it to come back down to test the landing, what they did was they attached it to the top of an airplane, and the airplane flew very high up in the sky and then detached itself, and then the shuttle was able to come back down to Earth in the testing phase to test if the shuttle could land correctly. So that's always a very cool picture because you don't see that very often, hardly at all. So then I just have some other pictures that kind of are cool for people for anyone who's interested in space or space exploration. A few weeks ago, a very important event happened, which was NASA's rover called Perseverance landed on Mars. So this picture on the left here shows the launch of this rover, which was last summer. So the rover was launched in July. It went all the way up. It spent about 7 months traveling to Mars' atmosphere. And then in mid-February, the rover reached Mars' atmosphere and safely landed on Mars. This picture kind of shows how the rover was able to land on Mars. So this rover, right now as we speak, is rolling around on Mars, taking pictures and sending information back to scientists and engineers working for NASA. So that was a very, very cool event. And then one last picture I have is just to explain how this rover transfers information back to Earth. So because Mars is so far away, we cannot get the information from our satellites. What NASA needed to do was actually send satellites up to go around the planet of Mars. So here's just a little example of the Mars Odyssey orbiter. That was a satellite that was deployed into Martian orbit. And this last picture here shows the satellite fully deployed, fully extended. And all it does is it goes around Mars over and over and over in circles, collecting information that the rover wants to send to scientists. So those are just some fun examples of things that have happened in the last decade for aerospace and space exploration. So that kind of concludes the presentation that I wanted to give to you.
Okay, well, we need to thank you. Your presentation has been really impressive. I think we are all surprised and we are all interested in how many aspects you can control from being an engineer and running these projects. And because you open an entire vision for what other areas of engineer can be improved or where the students could be working. I would like to thank you so much for this presentation, and I think the students are going to be really interested, and they are going to be searching from now on where they want to be or what they want to study, and this is being very helpful. We thank you so much.